Okay, so here we are. This is Draco Science, given to you in a way that is not what I had hoped for. The last part of the year, or at least the next part of the year, what we're going to be studying is matter and energy. And so we talked about space some, and we're going to link that to the origin of atoms. But for right now, I just want to talk a little bit about matter and energy. Matter being stuff that has mass, and energy being the stuff that moves matter. The idea of matter being made up of atoms is old. I think it was like 2,000 to 3,000 years ago. A guy named Democritus came up with the idea that matter, and that's stuff made of, that we know now is made of atoms, but stuff that has mass, he came up with the idea that it was something you could divide into smaller and smaller parts until you couldn't get any smaller. And so he theorized that that smallest particle of matter couldn't be divided. And so he named it that. Couldn't be divided. And if you knock over this camera, you're going to be in trouble. And so he gave it a name, atom. A is a prefix that means not, like asexual is not sexual, apolitical, not political, atypical, not typical, abiotical, not biological, meaning not being alive, and we'll come back to that later on in our discussion. So that was a pretty slick connection, in case you don't pick up on it later. So this is Mira pulling sticks around, and we're in the woods near my house in Putney, and we're talking about atoms. And so I talked a little bit about Democritus, and that was a long time ago. And then in the 1800s, right, so almost 2,000 years after Democritus, or 2,500 years, I don't really know when he lived, but in England, they did some experiments, and they came up with evidence that everything was made of atoms. What they did is they took a little quartz, they took a thin section of quartz. Quartz you might know of as what sand is made of. You might also have seen quartz crystals. All quartz has the same structure as a quartz crystal, and that is, it's six-sided. You've probably seen the crystals. Sometimes they can be rose quartz, sort of pinkish, or amethyst quartz, which is purplish, but they have that sort of pointy tip and then the flat sides, and I'm quite sure you've all seen it. And what they did is they took some quartz crystals and they cut it into really thin sections, and then they emitted X-rays, and you know X-rays to be a form of electromagnetic energy, right? And it's shorter than what we can see and has some danger because it's high energy, short wavelengths, high frequency. And then they had a screen over here that something they knew would turn white, or would turn white basically if there were X-rays incident upon it. And so what they did is they fired the X-rays and at the quartz thin section, and then they recorded where the X-rays hit. They ended up with something that was really amazing. It was one of the truly phenomenal discoveries by humans up to that time anyhow. And they found that there was a pattern exhibited on the X-ray, and what it was a hexagonal pattern. tiny little dots laid out in the shape of a hexagon, six-sided, like a snowflake or like a quartz crystal. Okay, so the underlying structure in quartz, the mineral, is a crystalline structure that is six-sided, and that's the hexagonal crystals that we see when we look at a quartz crystal is a result of that underlying structure. Another thing I want to tell you about quartz is it has a chemical composition. Si is silicon, O is oxygen 2. So one silicon atom and two oxygen atoms. That's a chemical that's a ratio of atoms. There isn't another kind of atom in quartz. It's silicon atoms and oxygen atoms. And we're going to get to that. But I just want to sort of give you a little preview, SiO2, and I want you to think about, why that ratio? Why one silicon and two oxygens? And kind of running out of things to say here. So I'll turn the camera off and see if I can know. Oh, there is something more I want to talk about. Because I used the abiotic as not biological, not alive. And I want to point to this pond here that you can see covered with ice. And this is actually called KaliePond. We named it today after a kid on Draco who's one of the nicest people you could ever imagine. And I want you to note that there's nothing going on in that pond. There's nothing alive. And if we take a closer look, I'll wiggle the camera around and try to get you a better look at it. You can see that there's no stream coming in and no stream going out. So this is a pond like the kettle ponds on Cape Cod that I hope Mr. Stark told you about. This is just a depression that water, that's full of water at this time of year. In the summer, if we came back here, it would be dry. You can see that tree growing out of the ice in the middle of the pond. It's, so it's not really a pond at all. And it's what's called a vernal pond or a vernal pool. The vernal equinox is a spring equinox. This is a pond that's only here in the spring. And we will talk about that because ultimately all this stuff, you're probably looking right into the sun there, sorry. Now you're looking right at me, even worse. But, a vernal pool, this looks like a lifeless place. It's silent. There's nothing living in there. There won't even be water in there in the summer. And in fact, let me just take you over here because there's another nearby pond called, so that was KaliePond, and this is Lake Bela, right? And you can probably figure out who it's named after. And it also, you can see that it narrows here a little bit, but it's not, it is, can be at times connected. Sorry, I probably moved that too fast. But there is no water flowing in or flowing out. This is another vernal pool or vernal pond, and there's a rock in the middle. Even on a sunny day, there are no turtles in there, or at least on that rock, because there are no turtles living in this. Right, so you could think of these as abiotic ponds. Okay, so we've talked a little bit about what we're going to study, matter, the connection to energy, and we've sort of given a little preview because stuff that's alive is really what matters. Okay, thanks.